Very warm welcome to everybody. Good evening, good day, good morning to all of you, wherever you may be today. I'll just share my screen right now and hope that you can see my slides. And that you can hear me. So today I will be telling a story about how we developed a new product, but it's going to be divided into two parts. How we came to this product, and then the second, more technical part about how this product looks like. So there will be something for everybody. There will be something for non-technical people. There will be also something for people with more IT background. So what's it all about today? I will first give you a brief history of enterprise content management because I assume you don't know what it is. Then I'll explain you what the problem is that we faced a couple of years ago. And this is the story part. And then I'll tell you how we solved it and basically where do we go from here. And we have plenty of time, 50 minutes. Should you have any questions, I would ask you to just ask them in the chat, and I will try to answer them right away. And if we run out of time, obviously I have 6 colleagues here with me today, and we are manning our product demonstration room and our virtual booth. And I will also be very happy to meet you there after the talk and just answer any questions you may have, show you the product, or just exchange experiences about what you're about to hear. So let's start maybe with a brief introduction. Who are we? Because you probably never heard about Optimal Systems. So we are a Berlin-based company. We are 500 plus employees. We were founded in '91, so we are a pretty established old company, you could say. And before April, I would proudly say independent company, and now I proudly say we're part of Kyocera Group from April this year, which opens us certain possibilities which we didn't have before. My role is CTO, and I'm heading an engineering department with around 80 people, and our job is basically to develop the product, to build the right product, to build it right, to build it fast. We have around 3,000 enterprise customers, so it's not a small customer base. And our core business is product development, ECM, Enterprise Content Management. It's mostly on premises, historically speaking, because we are almost 30 years old, and there was no cloud at that time. But we have increasingly growing cloud business, which is what I'm going to talk about today, actually. So to understand what the problem I'm addressing at all, to be able to understand what's it all about, I will give you a very brief history of content management. And I will start with telling you that it's not web content management. So people usually make this mistake when they hear enterprise content management, they think about web content management. So this is not the same. So what is enterprise content management? It started basically, as I said, 30 years ago as an archiving business, because the companies started digitalizing their document pools and they needed to store them, to archive them somewhere. And this was the start. And at some point, this grew into document management business, meaning not only storing documents as an archive, dead documents, but also being able to search efficiently, being able to work on documents, being able to control access rights. And then from this perspective, it even grew further by adding a business process management, because the documents which are not being shared, which don't participate in business processes, may as well be dead. And these two pillars, basically, document management and business process management, are the two basic pillars of enterprise content management. So basically, Our market is a vertical in which we help our customers to organize their digital documents in any way they see fit. So what problems did this approach solve? So what's the good about enterprise content management? So the basic problem it solved was records management. Records management means, I will give you a concrete example. If I'm a company having a lot of paper invoices, I'm able to digitize these invoices, either scan them or even receive them as PDFs. And I'm able to put them in logical structures, dossiers, files, folder, whatever. I'm able to put legal retention time on this document, say 10 years in Germany. And then I can shred the paper document. I can destroy the original document. This is records management. So this is the basic problem we are talking about here. Paperless, removing paper documents at all. The second thing that enterprise content management solved is document search and retrieval. Because obviously you want to be able to find the document that you archived at some point. You need it again. You may need to share it to somebody. You may have an audit. You may want to work on a document. And for that purpose, you also need version management. You need to know in which version is a document. You may need to retrieve the old version of a document. And then obviously document-based workflows. You want to share these documents with your colleagues. You want to share these documents with people outside of your company to work on them together. And you don't want everybody to have access on documents. So basically, obviously, access control is a very important part of this solution. So this is also a good thing, because if you have a document in Google Drive or a network drive, you have no idea who has the access to these documents. So this is not good enough. And with respect to that, obviously, audit and compliance. The ECM is a highly regulated market, and we all have thousands of certifications and validations, basically boiling down to the point you're able to destroy the paper document and just rely on a digitalized document. But there are some problems this approach failed to solve. So this is the bad part. So it's implicitly document-centric. It's not user-centric. It's based around the notion of a document and not what this document can do for a user. Furthermore, it's an approach which is now 30 years old. And in this approach, Word file is a document, which is nice, but maybe 4 gig log file is not a document. So things like AI, Internet of Things don't really fit into this approach of storing documents. And it is also based on basically copying file system. Basically, it's based on fixed structures such as folders, subfolders, sub-subfolders, and it requires implicitly navigation. And it's also severely over-engineered at some point. This is a real example. For example, you can define access rights, and you can inherit them over 30,000 levels of folders, and it needs to compute instantly. So this is severely over-engineered. I think nobody needs this actually. And because of this, it forces or favors navigation instead of exploratory search. So basically, you use it as a Windows Explorer. And it also generated some new problems. So this is the ugly. So I really hope nobody from my sales is watching this, because I'm killing our business. But this is the evolution of enterprise content management. This is where we are right now. It's really difficult to scale on premises. These software are monoliths with enormous footprint, and they're very expensive to maintain. And they're either commercial off the shelf or have very proprietary customizing, which leads inevitably to vendor lock-in or exploding projects, which when finished, don't appeal to the end user at all. And they're required to use with proprietary tools. And this is the worst part. They have hidden APIs which nobody knows about. So this is really ugly. And it promotes shadow IT in a very negative context, because it's expensive, not all people can use the ECM, and then the shadow IT just springs. So what's the problem? What's the problem we're trying to solve? Because you see, the ECM is a conservative solution from the 90s, and thus inevitably it found conservative customers, and it became this critical, super sensitive backbone of the company. Security, privacy, fault tolerance, compliance, you name it. And that's because the customers like the good records manager. They just accept or ignore the bad and the ugly. And there is also this never touch a running system. So it runs, but it doesn't need to be updated. It just runs. Nobody wants to know about it. But the problem is, nowadays, the volume is increasing. And the costs are horrendous of having this old software running on premises. And people are seeing everybody else is going to the cloud all the time, but why can't we go to the cloud? The customers are asking. And now I would enter the personas I'm going to talk about today. So these are basically chief architects or CIOs, really from different verticals. So we have, as an example, we'll have a library, we will have a civil service, we will have an airline, we will have a very big bank, we will have a machine manufacturer. And now they see the world is changing. They see new technologies, they see the cloud, and they're asking themselves right now this question. So can we use somehow these new technologies to keep the good? So records management, it needs to be. Yeah, I need to archive the documents, I need to find them again, I need to be compliant. But can we eliminate bad and ugly somehow with these shiny new technologies? And this is why they can't sleep at night today. Because they really need to scale massively, because the business is increasing and this degree of digitalization is increasing. They need to make these closed systems more open. They need to be able to use just the components they need from this system, because you all know the analysis of the old monolithic application service. People are buying them and using like 10% of features, but they need to run the whole monolith on premise. So this is the same. So they would really like to use the part. They would like it to integrate these parts with the rest of their landscape, and they're not able to do this in the old world. And they really require multi-tenancy to serve other departments, maybe to serve other customers. And why they require multi-tenancy? They want to save administration costs. They don't want to have 100 instances of a system. They want to have one instance of a system. And still, they need to satisfy very strict regulatory, industry, or even company requirements. You can't run away from this. This is a fact. They need to remain on premises, but do they really? And they really need to save much money. And especially now in a post-COVID world, all of us are going to make at some point losses in this year, and I expect everybody will recover at some time, but we will all be hard pressed to save costs, to cut costs in the next year. So these guys also need to save much money. And Google Drive is really not the solution they are looking for. So Google Drive can't help them. So how we solve their problem? So these are the concrete challenges they're faced with. So the civil service, it's actually a computing center. They want to store and retrieve hundreds of millions of sensitive documents. So we're talking about private documents of citizens. So these are like pension slips or tax return documents. And they need to enforce legally retention time of 30 years or even more. So they need to make it extendable. They want to integrate this storage for this huge volume of documents in their existing security system. They have it already in place, and they want to archive it on premise, and they want to scale effortlessly on premise, but have the option at some point in the future to move to the public cloud. Second example, airline. They need to store and retrieve all invoices to third-party suppliers. So everything basically they're paying. So these are outgoing invoices. So you can imagine the amount. And they need to enforce retention time of 10 years, which is legally. And they need the possibility of legal hold, so to extend these retention times if somebody sues them, for example, a supplier. They want to integrate this in existing portal of a company, And still they want to have strict separation of company divisions, so multi-tenancy. They want to serve all company divisions, which are many because it's a major airline, and they want to scale effortlessly, and they even accept public cloud. They don't have a problem with this. And then see what the library needs. This one I like the most. So the use case here is how can I store and retrieve the content of basically everything that has been published since Second World War and even earlier, I think, to today and in the future ever. And these are not just documents, these are not just text. This is about context streaming. They want to store audio, they want to store video. And retention time is forever. They also want to integrate this huge archive into a publicly available portal for the citizens. And obviously, they also want to scale effortlessly. And at some point, maybe move to the cloud. Bank, they have petabytes of log files. These are big files, as well as billions of SWIFT slips. These are a lot of files in a single system. So you have big files and a lot of files. And they also want to scale magically, effortlessly. Or the machine manufacturer. So their problem is they just want a compliance archive. They have like traffic of 100,000 more emails per day. They want to have them in real time archived. They want a complete full text analysis of every single email, including all attachments and attachments in attachments and so forth. And they want to have it in real time. They want to have it searchable in real time. And also, surprise, surprise, they want to scale effortlessly. So how to solve this? So this is not a trivial problem, as you see. So there are several options you can do. So I will first tell you how we didn't solve it. So these are the lessons learned. So we have a history of 30 years, and we have software on premises. And we did not solve this problem by taking the existing Windows monolith core. And then, as you read today, doing a stepwise extraction of functionality in form of microservices, and they scale magically all together, and they talk to each other magically together, and they even talk to the monolith magically. And we did not build individual setups for Windows, like maybe Bitrock or whatever, and Docker containers at the same time. We also did not build meaningless sidecars which do nothing with a monolith, just say, I'm there, but you don't have any idea what's happening in the core. We did not orchestrate these services on-premise and in the cloud. And we did not have to scale the monolith as well as microservices, which will lead basically to having multiple pipelines and platforms and quality assurance and. So this is nice. And doing this, basically taking your core and extracting one function after the other in form of a microservice may work in your case, but it didn't work in our case. And we just hit the wall, and we just saw that we are wasting time and money with this approach. And then we came up with a solution. And the solution is basically revolution instead of an evolution, because this evolutionary approach was a dead end for us. And the solution was an onion, as you can see. Why an onion? We built it from scratch. We could afford this to us because our core business runs so good that we really could afford to build this from scratch. And then we took some time and started by specifying some design criteria this software needs to fulfill. And if you see, they're all technical. So the guiding line here was performance and scalability before feature. So first design criteria was big data enabled. What we are seeing basically in our on-premise installations are numbers like hundreds of millions of documents. Very rarely it's 500 million or something, which is huge. But here we are talking about billions and tens of billions and hundreds of billions of documents in a single instance. So this is the revolution. The second criteria was having a layered architecture. So onion, this is this metaphor onion, which basically, speaking as a software architect, means having a small core of services which provides the basic functioning of a system, which basically has infinite scalability, which basically has no practical downtime, and is required for the correct functioning of a system. And then putting every other feature, which I will show you later, on top of this onion core as a layer. So it's basically layer upon layer upon layer with defined communication, but any function in the core is required to satisfy this strict dependability, reliability, performance, and fault-tolerant criteria. Because this, as you will see, because this was defined as a layered architecture, as a microservice architecture, it basically has no downtime because you can update services in a rolling manner. And it's also design criteria was to have no third-party software required. So it's Windows free, it's MS SQL free, it's Oracle free. Basically, you don't need anything to run it because it's purely Docker and Kubernetes based. This is also a very important decision when we design the system. There is no Windows setup. This is not a Windows server software anymore. So microservices are in Docker pods and they're orchestrated by Kubernetes. We took this decision like 4 years ago, and then it was nothing more than a good bet, but this paid off. And because of this, we're also basically, this system is basically cloud agnostic. You can run it in any cloud which supports Kubernetes, which is every one. And it even runs on premises. Actually majority of the customers using this product are running it on premises. Very interesting. But this is the value proposition of a system. If you're building such a system, you want to postpone this decision of having to move to the cloud. Again, we are in a very conservative area, very conservative markets. People are afraid of storing sensitive documents in the cloud. So if you promise them this, you can benefit from the cloud technology on premise and just migrate your code and your project to the public cloud at any point in future. This is a great USP for every CTO. Another design criteria was to provide low-level multi-tenancy. So this was the must. Everything is multi-tenant in this product. And basically, it's multi-tenant in a software as a service meaning of this word, meaning that you can host several instances, several customers, or thousands of customers in a single instance. And probably the most important decision was to make it API first, or actually API only. And we'll focus this in the second technical part of this talk. So this is basically the core of the system. These are the 5 core services. It doesn't look like much, but remember the onion analogy. Basically, as a colleague of mine who will be waiting for you in a product demo or a virtual booth likes to put it, what we basically build is S3 on steroids, or S3 with benefits, which you will see right now. Because it's a very small core, but that's also why it's very powerful. The first part is obviously registry. We want to register documents in a system. We want to be able to manage document metadata, data with described documents. So invoice or email or project plan or whatever. They have their attributes defined by a schema. The second part is repository or binary storage. We want to save the documents then physically. Blobs, we want to save them somewhere and be able to retrieve them. Index is our search endpoint. We want to be able to search for the documents. Version resources is everything pertaining to a project needs to be bundled in a version project because it enables very easy staging. So basically everything which defines the project in this system needs to be versioned. And ultimately, you need somehow to solve the authentication problem. So you need to know the user. So that's why we need identity provider. And that's it. These 5 basic services or service groups are the core of the system, represent the core of the system. And this is how it's realized. As I said, S3 on steroids, it's S3 is our basic storage. We have a relational database to restore document metadata, which is Postgres or Cockroach. Our search service is Elasticsearch. Obviously, for managing versions, what would you use if not Git? And as authentication bridge, we use Keycloak. And this is the same thing, but just in a more complex manner. This is how we deploy it in Kubernetes. So in the upper part of a picture, you can see the microservices as they are implemented technically. So the previous picture was more like an overview, and these are actual services we have in the platform. But more important, I think, for this one is the lower part of the picture. We just provide a Helm infrastructure charts, which map those services to an infrastructure element such as Postgres or Cockroach, as I said, Elastic is a search engine, Minio or Azure Blob Storage, or even a storage appliance. If you use it on premises, you can just plug any storage appliance like NetApp SnapLock or ICAS or Dell ECS or whatever you like, you prefer. Gogs as Git, RabbitMQ as messaging bus, Keycloak, and Redis for caching. And this is the core of the system. If you look at the right-hand side of the upper picture, you will see also a client service. And this is an example of a non-core service. And you can see this on this picture. So this is the architecture which is now expanded by adding non-core or peripheral services. So as I said, the core has very strict requirements pertaining to several parameters, such as performance, reliability, and fault tolerance. And they're given, they are low. However, if you need to extend the functionality of the system, you can add peripheral services, such as maybe business process management, workflow management, or more advanced document lifecycle, or even a client service. And we have built just one client service, which basically has 2 components. It has an Angular web application and a web API gateway, which then consumes the core API and just provides the web application with appropriate API so that it does not need to consume the raw API I'm going to show you a bit later. And using this philosophy, we are extending this platform further. As I said, it's about content management. It's about document management. What's the difference between this system and some sort of an object store? It's a schema. And a schema makes the document management intelligent. It gives semantics to the otherwise unstructured content. Basically, we do 2 things. We classify each binary object. So every object has a type. It can be, as I said, an invoice, an offering, an email, or whatever you want it to be. So this is classification. And it has metadata or attributes. You can think about it as a class definition or entity relationship diagram or whatever. It's basically that. You define a schema you want your system to support. You give meanings to your documents by classifying them and giving them attributes. And there is also a nice thing about it, having the so-called secondary object types, meaning delegation. So basically, you can extend your documents with additional attributes. So something like inheritance, but it's more like a delegation. And schema is also multi-tenant, very important. I will come to that later. Let me give you an example of a schema. So this is just an XML. So there is an XSD, and you can just validate your schema. And what you see here on the left side is that what you see here is the definition of an email type. So we want to store emails in our system. We want to have some metadata about emails. So that's it, basically. So you can see that you define a schema by defining fields, their types, attributes, and constraints. You can see here a field which we'll call from, which will have a type of a string, and it's a required field. We have a field to, we have field subject, and we have a field received. These three fields have a type string, and this one is a date type. So now you defined attributes, and you just group attributes in a class or object type, or we call it object type or document type, and you just say it's an object type in email, and it has the following references, the following attributes. So these attributes are important because you will be able to instantiate them when you create an email object, and you will be able to search using this metadata later. And there is a nice thing here at the lower right part. It's this extension, delegation. So what we did here, we extended this email type by a secondary object type of a contract. And imagine that the contract has additional fields, such as this would make the example too big. But imagine that the contract has additional fields, such as amount or supplier or something. Then these fields will be searchable also on the object type email. So it's as easy as that. Multi-tenancy is a major aspect of this system. And multi-tenancy means that you basically can have one system and one schema, and you can serve it to different tenants, and they're strictly separated. There is no way a single tenant can access documents of another tenant. It is physically impossible. We can also provide so-called, so this is the global schema. You have a global schema. So what we did here, you can say this is the global schema. Every tenant of a single instance of the system has access to or is able to create and search and retrieve objects of this type. And this is a global schema shared by all tenants. And then you can even do the following. You can define local schema, which is specific for a single tenant, and extend the global schema, enabling tenant-specific customizing, which means that each tenant can extend his own schema, and in runtime, these two will be merged. You would have a tenant-specific schema merged with a global schema. The core of this product is its API. And it's a REST API. It's a modern API, which conforms to Open API specification. And currently it's dividing into three spaces, I would say. It's document, so DMS stands for document management. So it's a DMS API, admin, administration, and system. And very briefly, I will show an excerpt from this. You see Open API logo there. And it's all I can tell you, if you don't understand the API just by reading it, you design it in the wrong way. So if you read the first post, it's post object. So obviously it imports an object. Delete object with object ID, it obviously deletes an object with a given object ID. If you say get request objects object ID, it obviously retrieves an object with a given ID, and so forth. So it really needs to be self-explanatory. The grammar, the verbs, it really needs to be So take a look at the patch, for example. This is a nice example of using the grammar. If you say patch objects with an object ID, it will obviously update only those metadata which you provide, whereas post will override all metadata, nulling those that you don't provide in a post request. So if you follow this, you can really build a powerful API, and obviously with Swagger, you can test it in a second. We'll just take a look at the Postman collection we provide for this. And what I found actually astonishing is that this API was understood. We did some tests, obviously. We did some tests by providing this API with documentation to people who had no connection to enterprise content management at all, to developers, and they understood it in like 2 hours, and they started hacking with this. So this is what the clear API definition will bring to you. Obviously, there are also system and administration API, which can enable you, but again, it's a very self-explanatory. You can validate schemas, you can update schemas, you can retrieve schemas in the administration part, or in the system part, you can do everything with a global schema. I will just briefly, very briefly show you what it looks like. I hope you can see my postman here. So we just store a single document in a system. So we are now connected to a live Azure system, and I will just post a document. So as you see, I'm creating a multi-part request, multi-part post request, storing a document. I'll just send this request, and I just got a return. It's 200. Everything is okay. We just save the document, and in this response, I also have the document ID. Here, I can get document metadata. So basically, I didn't show this to you. I had a small file defining the metadata of a document, but we don't need to do this. Let me just get document metadata very fast for you. So now you can see the document metadata. Version number is 1. There is the metadata attribute of name. It has a string value, and there are some system properties. And then there is a content stream part. So it's a binary part of an object. We can also get document content by ID. We can also perform search first. Maybe let's just perform a search very fast. We'll come to this later. So we can just use our SQL search and select star from all documents with a full text search where the metadata or content contains the word Endor, and we have this hit, we have object ID, and we even can then get document content by this ID. Let's just replace it here very fast and send it. And after a second, we will have the content of this document. So it's Battle of Endor. And of course, I can delete this document. And it's deleted. And if I'm very fast now and do the search again, maybe I can show eventual consistency, but no, it's already deleted. Obviously, what could have happened is that the index was not updated, but we are very fast, so it's not in the index anymore. So this is not intended to be a demonstration, a full-fledged demonstration, just to have for you to have a look and feel what's it about. My colleagues in both booths are happy to present you in a more detail, to explain you this. And I will just go further in the architecture part and tell you a bit more about how we built this product. Obviously, you need some sort of authentication authorization, because access control is a crucial part of such a system. OAuth2 is a must today, basically. So that's why we shipped it with Keycloak as a provider or bridge. And access to each object is controlled by role membership in the system. And every role carries a condition which is evaluated, and it controls permissions such as read, delete, update, and stuff. And you can have an example of this role set on the right-hand side, where we have a role called manager, and it has permissions of types read and delete if these conditions are satisfied. Basically on object types, dossier, case, and document. So if you authenticated user has a role manager and is trying to read or delete object of types dossier, case, or document, the user will be authorized, otherwise not. Or you can define a second role, as you see, a QA manager, which has permissions read and delete on all object types which begin with QA. How we implemented it is very interesting. We basically do it by filtering the metadata or object types. Basically just adding a clause in a search query. Why is this interesting? It enables us to integrate. So you remember our use cases. So for example, a civil service provider, they already have a security system in place. It's a very sophisticated security system. And what they want to do is to keep using them. And using this very simple but very powerful and efficient way of or authorizing users just by checking the metadata on a document itself, enable them just to keep their own security system and integrate in our role set system very easily. Very important part of this is also versioning and audit trail. All objects are versioned. If you look at the API specification, you can also see that some of the calls have version ID parameter, which means that you can access the complete history of changes of every object. And you can revert versions and do stuff. You can delete versions. And furthermore, every access to the system is logged. So this is audit proof. There is no way around. This is very important for compliance. But the system also provides a very fast text analysis. It provides almost immediate access to full text content of any file. And there are two ways you can do this. The first is by doing it in a synchronous manner, and the second is obviously asynchronously. And I will give you an example of how to do it asynchronously using messaging, but default is synchronously. So basically in real time, you import a document, you analyze the document, you write full text information in Elasticsearch, and then it's instantly searchable, which is a great feature. Think about the use case of a national library. They're storing streams, and those can be text streams or PDF streams, but they can also be audio or video streams. And now it becomes difficult. And this API brings a very nice feature within it, which is basically compound documents. This means you can treat a single binary document, a stream, and store it physically as a blob, and logically divide this document based on offsets in logical individual documents, each with its own metadata set. Meaning that from a huge compound document, you can build thousands or tens of thousands of logical documents. Think about the scenarios not only about storing PDF streams, think about scenarios of storing video streams, where then you can maybe asynchronously do an AI processing and tag offsets in a document, in a stream, where something happens. Think about surveillance videos being maybe tagged in real time with this system. So you can really do a lot of stuff with compound documents. When we designed the system, we started with the idea not to provide every possible feature in the product, because then it doesn't scale and it will break many performance rules we set. Instead, we said a modern API product needs to be extendable. You can't keep it closed. And that's why we introduced server-side customizing in form of interceptors. Interceptor is a design pattern which basically inserts alternative processing calls to a given API call. It can be based on metadata or maybe a role of the active session. And then you can implement the logic in a custom microservice. And we provide you with two meanings to intercept this API call. One is using AMQP hooks. AMQP stands for Advanced Message Queuing Protocol, which basically enables you to generate messages in a messaging queue if something happens, if a condition is met, which you defined in a hook. And then some other service reacts, subscribes to this queue, and then consumes the message, and you get the idea, it's messaging. So it's asynchronous. Or the other way around is intercepting an API call and calling an HTTP endpoint synchronously in this case, which is a webhook. And I will give you two examples of this possibility. One is basically, for example, doing a server-side control field visibility. So this is a common problem in enterprise content management. You have an object of a type contract, and you have maybe contract amount, which should be confidential metadata for a role employee. So if an employee search for a contract, he should not receive this metadata, but the manager should receive this. Implementing this in a general case kills the performance of a system. Intercepting just specific object types and then deciding which part of a metadata set you want to provide in an API call, which will be a search call that you saw right now in Postman, based on the role of the active session, is very easy to use, very easy to do using this system. Or the more complex case using AMQP hooks is maybe doing asynchronous text extraction. So this is a good example how this is a more complex example, but this is something you can do. You can define a system hook using spell, which is not spell, but it's almost like a magic. This is string expression language on the left-hand side, which basically evaluates a predicate, which you define in a hook. And what you see here, I'll just translate this to you. If a call of inserting an object has a content stream, meaning it has an object, and if it's bigger than 0, and if it has multiple parts, then send a message to this queue, text extraction. After the message is being sent, the controller is to read this message and publish a new message in the new queue, taking a bulk of 10 documents and taking each document from this big compound document as a single document, performing a text analysis, writing this in Elasticsearch as a single document, and giving the control back. And in that way, you can perform an asynchronous text extraction of huge files, of component files in a very flexible way. And the last feature I'm going to talk to you about, because the time is running out, is search. So search is the cornerstone of a system. And basically, we developed a SQL language, or inspired by SQL, which enables you to perform almost any kind of search in the system against Elasticsearch. And this is being then transferred in Elastic Query language in the background. So what you can do here, you can do queries with placeholders, such as select star from invoice. So the first query will basically search for all document types invoices, where amount is less than 10 or more than 100, and the supplier is in these two companies. Or you can query combined with full text search with ranking. So you can use the function score, and you can do this clause contains. So you can basically search for all object types of the type invoice, where amount is bigger than 100, and somewhere in full text in the content or metadata, there is a word reminder. And you will even have order by computed score, quality. Or you can do full text within the attributes. So in the third example, you select star from invoice, so from the object type invoice, where the field status contains any of these words, deadline, overdue, penalty. You can do aggregation, so you can do select count star, group by. You can even do a secondary object type search. You can use a lot of predefined functions such as date. So the one is very interesting, the one before last. This query will basically give you all the documents which retention time ran out. Or even you can query with our audit system. So for example, you can see all audit entries for a given trace ID. As the last part, the question is, where do we go from here? What are we working on right now is AI. Obviously, everybody is working on AI, but this makes sense because what we want to do is to be able to automate this process of classifying and indexing documents. We want to be able to provide finished models, which you can very easily deploy or even use it out of a predefined API and just drop a document to an endpoint, and you receive a JSON with an object type and metadata. We're also performing integration with Flowable at this point. We have built a repository manager and a client, which will come out in a few weeks. And we are thinking about supporting hybrid scenarios with service mesh, because our customers, almost all of them, are in some sort of a service mesh. Very rarely do they work exclusively on-premise or only in the cloud. So this is the future. I'm strongly convinced that making this possible in a hybrid scenario where you have some payload, some workload on the premise and some workload on the cloud is the future. What you just saw is currently available in 2 flavors. This is DeveloperWeek.com, which is our managed API product in Azure. You can just register and test it. Or it's also available in a public cloud variant where you can get infrastructure Helm charts and you can just deploy it in your own cloud account. And this should all lead us to the vision, we just started with this, of A, making the customers happy, obviously, but having this vision of becoming, for content management in the cloud, what Salesforce is for CRM. Basically, enabling the customers both to consume software as a service application from the cloud and build them themselves in the same environment. So I think I'm out of time. I would like to thank you for your attention. I hope that you learned something, that this was interesting for you. And I would like to thank you for your time and attention. I would like you to invite to chat with me in our demo room or our virtual booth. My colleagues are also there. We will be happy to answer any question from you, maybe hear about your feedback in similar situations. So thanks again, and bye-bye for today from Berlin. Thanks again. Bye-bye.